Question 1. What factors determine the most effective approach to optimizing the lifecycle management processes for VMware Tanzu Kubernetes clusters? Option A. The extent to which new, unproven Tanzu features are adopted without thorough integration testing. Option B. The degree of automation and standardization applied to cluster provisioning, configuration, and upgrades. Option C. The prioritization of immediate cost reduction over robust monitoring and disaster recovery capabilities. Option D. The reliance on manual intervention and ad hoc scripting for routine operational tasks. The correct answer is B. The degree of automation and standardization applied to cluster provisioning, configuration, and upgrades. Explanation. The scenario involves optimizing the process of deploying and managing Kubernetes clusters using VMware Tanzu. This is professionally challenging because it requires balancing efficiency, cost-effectiveness, security, and adherence to operational best practices within a complex, dynamic environment. Decisions made here directly impact application availability, performance, and the overall cost of cloud infrastructure. Careful judgment is needed to select approaches that are scalable, maintainable, and align with organizational policies and industry standards. The correct approach focuses on establishing clear, automated, and repeatable processes for cluster lifecycle management, including provisioning, configuration, upgrades, and decommissioning. This aligns with the principles of infrastructure as code (ISC) and GitOps, which are foundational to modern Kubernetes operations. By leveraging these methodologies, teams can ensure consistency, reduce manual errors, improve auditability, and accelerate deployment cycles. This represents best professional practice because it directly supports the goals of efficiency and reliability mandated by operational excellence frameworks. It also implicitly supports security by enabling consistent application of security policies and patches. An incorrect approach that relies heavily on manual intervention and ad hoc scripting introduces significant risks. This failure to automate and standardize processes leads to inconsistencies across clusters, making troubleshooting difficult and increasing the likelihood of human error during critical operations like upgrades or configuration changes. This can result in security vulnerabilities if patches are not applied uniformly or if configurations deviate from established baselines. Furthermore, it hinders scalability and agility, as manual processes do not lend themselves to rapid expansion or adaptation to changing business needs. Another incorrect approach might involve prioritizing cost savings above all else, potentially by neglecting essential operational overhead like robust monitoring, logging, or disaster recovery planning. While cost optimization is important, compromising fundamental operational integrity can lead to higher long-term costs due to downtime, data loss, or security breaches. This approach fails to consider the total cost of ownership and the business impact of operational failures. A third incorrect approach could be to adopt new technologies or features without proper evaluation, testing, or integration into existing workflows. This shiny object syndrome can lead to technical debt, compatibility issues, and increased operational complexity, ultimately hindering rather than optimizing processes. It demonstrates a lack of disciplined adoption and integration, which is crucial for maintaining a stable and efficient operational environment. Professionals should employ a decision-making framework that prioritizes a holistic view of operational processes. This involves understanding the business objectives, assessing current operational capabilities, identifying bottlenecks, and then evaluating potential solutions based on their impact on efficiency, reliability, security, and cost. A phased approach to implementation, with thorough testing and validation, is essential. Continuous improvement through feedback loops and performance monitoring should be integrated into the process. Adherence to established operational frameworks and best practices, such as those promoted by VMware Tanzu for Kubernetes operations, provides a solid foundation for making informed and effective decisions. Question 2. When evaluating process optimization within a VMware Tanzu Kubernetes operations environment, which of the following strategies most effectively enhances operational efficiency and reliability while adhering to best practices for continuous delivery and stability? Option A. Introducing complex, untested automation scripts for infrastructure management without establishing clear rollback procedures or performance baselines. Option B. Focusing exclusively on reducing infrastructure costs by deprovisioning resources aggressively without assessing the potential impact on application performance and availability. Option C. expediting the deployment process by bypassing pre-production testing phases and directly releasing new application versions to the production environment to meet aggressive feature timelines. Option D. Implementing comprehensive automated testing at various stages of the CI/CD pipeline, integrating continuous monitoring for early anomaly detection, and adopting a progressive rollout strategy for new deployments. The correct answer is D. Implementing comprehensive automated testing at various stages of the CI/CD pipeline, integrating continuous monitoring for early anomaly detection, and adopting a progressive rollout strategy for new deployments. Explanation. This scenario presents a common challenge in cloud-native operations, balancing the need for rapid deployment and feature iteration with the imperative to maintain stable and secure production environments. The professional challenge lies in identifying and implementing process optimizations that demonstrably improve efficiency and reliability without introducing undue risk or violating established operational standards. Careful judgment is required to distinguish between superficial changes and fundamental improvements that align with the principles of robust Kubernetes operations. The correct approach represents best professional practice because it focuses on measurable improvements in the CI/CD pipeline's efficiency and reliability. By implementing automated testing, continuous monitoring, and staged rollouts, operations teams can proactively identify and mitigate issues before they impact end users. This aligns with the core tenets of site reliability engineering, SRE, and best practices for Kubernetes operations, emphasizing a data-driven approach to process improvement and risk reduction. The focus on reducing manual intervention and increasing automation directly contributes to operational stability and reduces the likelihood of human error, a key consideration in regulated environments where consistency and auditability are paramount. An incorrect approach that prioritizes speed over thoroughness, such as deploying new features directly to production without adequate testing or validation, represents a significant regulatory and ethical failure. This bypasses critical quality gates and increases the risk of service disruption, data corruption, or security vulnerabilities. In a professional context, this demonstrates a disregard for operational integrity and a failure to uphold the duty of care to users and stakeholders. Another incorrect approach, such as implementing complex, untested automation without proper rollback strategies, introduces new risks. While automation is desirable, its implementation must be carefully managed to avoid creating new points of failure. This can lead to unintended consequences and operational instability, failing to meet the professional obligation to maintain a secure and reliable system. A third incorrect approach, focusing solely on cost reduction without considering the impact on operational resilience, is also a failure. While cost efficiency is important, it should not come at the expense of system stability, security, or performance, which are fundamental to professional responsibility. Professionals should employ a decision-making framework that begins with clearly defining the desired outcomes of process optimization, e.g., reduced deployment time, fewer incidents, improved resource utilization. This should be followed by a thorough assessment of the current state, identifying bottlenecks and areas for improvement. Potential solutions should then be evaluated based on their potential impact, feasibility, and alignment with established best practices and any applicable regulatory requirements. Pilot testing and phased implementation, coupled with continuous monitoring and feedback loops, are crucial for validating the effectiveness of chosen optimizations and making necessary adjustments. This iterative, data-driven approach ensures that process improvements are both effective and sustainable. Question 3. Market research demonstrates that organizations are increasingly pressured to accelerate their software delivery cycles for VMware Tanzu Kubernetes environments. A key operational team is tasked with optimizing their deployment pipelines to achieve faster releases without compromising stability or security. They are considering several strategies to achieve this. Which of the following approaches represents the most effective and compliant method for optimizing their Tanzu Kubernetes deployment processes? Option A. Focus optimization efforts solely on individual deployment steps in isolation, without considering the end-to-end pipeline's impact on overall system health and security. Option B. Implement a phased approach to pipeline optimization, focusing on integrating automated security scanning and comprehensive integration testing at critical stages, alongside robust monitoring and rollback capabilities. Option C. Expedite releases by bypassing automated security scans and comprehensive integration tests for new deployments, prioritizing rapid feature delivery above all else. Option D. Develop and deploy broad, untested automation scripts across the entire deployment pipeline to maximize efficiency without implementing granular controls or rollback mechanisms. The correct answer is B. Implement a phased approach to pipeline optimization, focusing on integrating automated security scanning and comprehensive integration testing at critical stages, alongside robust monitoring and rollback capabilities. Explanation: scenario analysis. This scenario presents a common challenge in cloud-native operations, balancing the need for rapid deployment and feature iteration with the imperative to maintain stable, secure, and compliant Kubernetes environments. The pressure to deliver new services quickly can lead to shortcuts or the adoption of unproven practices, potentially introducing risks that violate operational best practices and regulatory expectations for system integrity and data protection. The complexity of Tanzu for Kubernetes operations, with its distributed nature and integration points, amplifies these challenges, requiring a nuanced understanding of process optimization that considers the entire operational lifecycle. Correct approach analysis. The correct approach emphasizes a phased, iterative improvement of deployment pipelines, integrating automated testing and security scanning at critical junctures. This aligns with the principles of continuous integration and continuous delivery, CI/CD, as advocated in modern operational frameworks and is crucial for maintaining compliance. By systematically identifying and addressing bottlenecks, and by embedding quality gates, the team ensures that new deployments are not only fast but also reliable and secure. This proactive stance minimizes the risk of introducing vulnerabilities or operational instability, which are key concerns in regulated environments. This approach fosters a culture of quality and security by design, directly supporting the operational integrity expected by regulatory bodies overseeing cloud infrastructure. Incorrect approaches analysis. One incorrect approach involves prioritizing speed over thorough validation by skipping automated security scans and comprehensive integration tests for new deployments. This directly contravenes best practices for operational stability and security, increasing the likelihood of deploying compromised or unstable applications. Such a failure could lead to data breaches or service disruption, potentially violating data protection regulations and service-level agreements. Another incorrect approach is to implement broad, untested automation scripts without granular control or rollback mechanisms. While automation is key, a lack of careful planning and testing can introduce systemic failures. If these scripts malfunction, they could destabilize the entire Kubernetes cluster, leading to widespread outages and non-compliance with availability requirements. This approach demonstrates a failure to manage operational risk effectively. A third incorrect approach focuses solely on optimizing individual deployment steps without considering the end-to-end pipeline's impact on overall system health and security. This siloed optimization can create new bottlenecks elsewhere or introduce dependencies that are not adequately managed, leading to unforeseen issues. It fails to adopt a holistic view of process optimization, which is essential for robust and compliant operations. Professional reasoning. Professionals should adopt a data-driven, iterative approach to process optimization. This involves 1. Baseline assessment, understanding current pipeline performance, identifying key bottlenecks and failure points. 2. Prioritization, focusing optimization efforts on areas with the highest impact on stability, security, and efficiency. 3. Incremental implementation, introducing changes in small, manageable steps with thorough testing and validation at each stage. 4. Automation with control, leveraging automation for efficiency but ensuring robust monitoring, alerting, and rollback capabilities. 5. Continuous feedback, establishing mechanisms for ongoing feedback and performance monitoring to identify new optimization opportunities. This structured approach ensures that process improvements contribute to, rather than detract from, the overall operational resilience and compliance posture of the Tanzu Kubernetes environments. Question 4. The monitoring system demonstrates a significant increase in API latency for a critical microservice within the VMware Tanzu Kubernetes environment, impacting user experience. What is the most effective initial approach to diagnose and address this issue? Option A. Immediately restart the affected microservice and its associated pods to clear any potential transient issues. Option B. Escalate the issue to the development team for immediate investigation without performing any preliminary analysis. Option C. Analyze request traces and resource utilization metrics for the affected microservice and its dependencies within Tanzu observability to identify bottlenecks or error patterns. Option D. Focus solely on the underlying Kubernetes node resource utilization, CPU memory, where the microservice is deployed. The correct answer is C. Analyze request traces and resource utilization metrics for the affected microservice and its dependencies within Tanzu observability to identify bottlenecks or error patterns. Explanation. This scenario presents a common challenge in cloud-native operations, identifying the root cause of performance degradation when multiple interconnected services are involved. The professional challenge lies in efficiently and accurately pinpointing the source of the issue without causing further disruption or violating operational best practices. The VMware Tanzu for Kubernetes Operations Professional Certification emphasizes the ability to diagnose and resolve issues within a Kubernetes environment, which often involves understanding the interplay between applications, underlying infrastructure, and observability tools. The correct approach involves a systematic investigation that leverages the capabilities of the monitoring system to correlate events and identify anomalies. This aligns with professional best practices by prioritizing data-driven decision-making and minimizing the impact of troubleshooting. Specifically, focusing on the Tanzu observability platform's ability to trace requests across microservices and identify resource contention or application-level errors is crucial. This methodical approach ensures that the resolution is targeted and effective, preventing the escalation of the problem and maintaining service availability, which is a core tenet of operational excellence and implicitly supported by regulatory frameworks that mandate service reliability. Incorrect approaches fail to adhere to these principles. Blindly restarting services without understanding the underlying cause is a reactive and potentially disruptive measure. It risks masking the true problem, leading to recurring issues, and could violate operational procedures that require documented root cause analysis before remediation. This approach lacks the analytical rigor expected of a professional and could lead to service outages or data loss, which would have significant regulatory implications if service-level agreements (SLAs) are breached. Another incorrect approach is to immediately escalate to the development team without performing initial diagnostics. While collaboration is important, a qualified operations professional is expected to conduct a first-level investigation. Premature escalation wastes valuable time and resources, and it bypasses the opportunity to gather crucial data that would aid the development team. This can be seen as a failure in due diligence and could lead to delays in resolution, potentially impacting compliance with operational standards. Finally, focusing solely on infrastructure metrics without considering application-level telemetry is an incomplete diagnostic strategy. In a microservices architecture, performance issues often stem from application logic, inter-service communication, or data processing bottlenecks, not just CPU or memory utilization. This narrow focus can lead to misdiagnosis and ineffective solutions, prolonging the outage and potentially violating operational guidelines that mandate comprehensive problem assessment. The professional decision-making process should involve 1. Acknowledging the alert and its severity. 2. Consulting the monitoring system for correlated events, traces, and logs. 3. Identifying the most likely area of impact, e.g., specific service, cluster, or resource. 4. Formulating a hypothesis based on the observed data. 5. Testing the hypothesis through targeted queries or diagnostic actions. 6. If necessary, escalating with well-documented findings. This structured approach ensures that actions are informed, efficient, and aligned with professional standards for operational management. Question 5. Process analysis reveals that team proposes to integrate VMware Tanzu for Kubernetes operations into an existing production Kubernetes cluster that supports sensitive customer data. The team is eager to leverage Tanzu's advanced features for application deployment and management. What is the most critical initial step to ensure a responsible and compliant integration? Option A. Proceed with the integration immediately, relying on the vendor's best practice guides to expedite deployment and realize the benefits of Tanzu. Option B. Prioritize the technical benefits and advanced features of VMware Tanzu, assuming that security and compliance will be addressed as a secondary concern after initial deployment. Option C. Deploy the new technology to a separate, non-production environment and only proceed if it functions as expected from a technical perspective. Option D. Conduct a comprehensive impact assessment that thoroughly documents proposed changes, analyzes potential risks to service availability, security, and compliance, and outlines mitigation strategies. The correct answer is D. Conduct a comprehensive impact assessment that thoroughly documents proposed changes, analyzes potential risks to service availability, security, and compliance, and outlines mitigation strategies. Explanation. Scenario analysis. The scenario presents a common challenge in cloud-native operations: the need to introduce a new, potentially disruptive technology, VMware Tanzu, into an existing Kubernetes environment. The professional challenge lies in balancing the benefits of innovation with the imperative to maintain stability, security, and compliance within the operational framework. A hasty or poorly planned integration can lead to unforeseen outages, security vulnerabilities, and non-compliance with established operational policies, and potentially regulatory requirements if the underlying infrastructure supports regulated workloads. Impact assessment is critical because it forces a structured evaluation of these risks and benefits before implementation, ensuring that all stakeholders are aware of potential consequences and that mitigation strategies are in place. Correct approach analysis. The correct approach involves a comprehensive impact assessment that meticulously documents the proposed changes, analyzes potential risks to existing services, security posture, and compliance adherence, and outlines mitigation strategies. This aligns with best practices in IT service management and operational governance, which are implicitly expected within the scope of professional Kubernetes operations. Specifically, for a regulated environment, this process would ensure that any changes to the platform do not inadvertently violate data residency, access control, or audit trail requirements mandated by relevant authorities. The assessment serves as a proactive risk management tool, enabling informed decision-making and demonstrating due diligence. This methodical approach is essential for maintaining operational integrity and meeting the implicit professional standards of responsible technology deployment. Incorrect approaches analysis. Implementing the new technology without a formal impact assessment is a significant regulatory and ethical failure. It bypasses critical risk identification and mitigation steps, potentially exposing the organization to security breaches, service disruptions, and non-compliance. This demonstrates a lack of due diligence and a disregard for established operational governance. Deploying the technology in a production environment solely based on vendor documentation, without considering the specific operational context and existing controls, is also professionally unacceptable. This approach ignores the unique risks and dependencies within the organization's infrastructure and could lead to unforeseen conflicts or vulnerabilities. It fails to meet the professional obligation to ensure that new technologies integrate safely and securely within the existing operational landscape. Focusing only on the technical benefits of the new technology while neglecting potential impacts on security, compliance, and existing service level agreements, SLAs, represents a narrow and irresponsible approach. This oversight can lead to regulatory violations if the neglected aspects are subject to specific mandates, and it breaches the professional duty to consider the holistic impact of technological changes on the organization. Professional reasoning. Professionals in Kubernetes operations must adopt a structured, risk-aware approach to technology adoption. This involves a continuous cycle of planning, assessment, implementation, and monitoring. When introducing new technologies like VMware Tanzu, a formal impact assessment is a non-negotiable first step. This assessment should involve cross-functional teams, including security, compliance, and operations, to ensure all potential ramifications are considered. The decision-making process should prioritize stability, security, and compliance, with technical innovation being a secondary consideration that must not compromise these primary objectives. Professionals should always ask, what could go wrong and how will we prevent it or recover from it? This proactive mindset, grounded in thorough analysis and adherence to established governance, is the hallmark of professional practice. Question 6. Benchmark analysis indicates that a new microservices application, designed to process personally identifiable information, PI, for a financial services firm, is being deployed onto a VMware Tanzu Kubernetes grid cluster. The firm operates under a strict regulatory framework that mandates data encryption at rest and in transit, granular access controls, and comprehensive audit logging for all PII processing activities. The operations team is under pressure to accelerate deployment timelines. Which of the following approaches best balances rapid deployment with the stringent regulatory requirements for PII handling? Option A. Implement automated security and compliance checks within the CI/CD pipeline, including policy as code for access controls and encryption configurations, and integrate continuous auditing of PII access logs. Option B. Focus solely on application functionality and performance during the initial deployment, deferring all security and compliance configurations to a later phase after the application is stabilized. Option C. Deploy the application immediately to meet the accelerated timeline and schedule a separate post-deployment security and compliance audit to address any identified gaps. Option D. Rely on the inherent security features of the Tanzu platform and assume that standard configurations are sufficient for PII handling, with manual audits conducted quarterly. The correct answer is A. Implement automated security and compliance checks within the CI/CD pipeline, including policy as code for access controls and encryption configurations, and integrate continuous auditing of PII access logs. Explanation. This scenario presents a common challenge in cloud-native operations, balancing the need for rapid deployment and innovation with robust security and compliance requirements. The professional is tasked with implementing a new Kubernetes-based application that handles sensitive customer data, necessitating strict adherence to data privacy regulations. The challenge lies in selecting an approach that not only meets the technical demands of the application, but also satisfies the stringent regulatory framework governing data handling within the specified jurisdiction. The correct approach involves a comprehensive security and compliance review integrated into the CI/CD pipeline, leveraging automated policy enforcement and auditing. This aligns with the principles of security by design and compliance by design, which are fundamental to modern regulatory frameworks for data protection. By embedding security and compliance checks early and continuously, the organization minimizes the risk of non-compliance and data breaches. This proactive stance is crucial for demonstrating due diligence and maintaining customer trust, which are paramount in regulated industries. Incorrect approaches fail to adequately address the regulatory landscape. Implementing security measures only after deployment, without prior validation against compliance policies, creates a significant risk of post-deployment remediation, potential service disruption, and regulatory penalties. Relying solely on manual audits is inefficient, prone to human error, and cannot provide the continuous assurance required for sensitive data. Furthermore, prioritizing speed of deployment over documented compliance procedures can lead to a false sense of security, leaving the organization vulnerable to audits and legal repercussions. The professional decision-making process should involve a thorough understanding of the applicable regulatory framework, including data privacy laws and industry-specific compliance mandates. This understanding must then be translated into concrete technical controls and automated processes within the Kubernetes operational environment. A risk-based approach, prioritizing controls for the most sensitive data and critical compliance requirements, is essential. Continuous monitoring, auditing, and regular reevaluation of security and compliance postures are also vital components of a mature operational strategy. Question 7. The risk matrix shows a high likelihood of security vulnerabilities being introduced into the production Kubernetes cluster through the use of unvetted container images from external registries. Development teams are pushing for faster release cycles, and manual image scanning and approval processes are becoming a bottleneck. Which of the following approaches best addresses this operational challenge while adhering to security best practices and potential compliance requirements for secure software deployment? Option A. Temporarily disable image scanning and policy enforcement for all deployments to accelerate release cycles, with a plan to re-enable it later. Option B. Implement an automated image scanning and policy enforcement mechanism within the CI/CD pipeline that blocks deployments of images failing predefined security and compliance checks. Option C. Instruct development teams to only use images from a curated list of trusted public registries without implementing automated scanning. Option D. Rely on runtime security monitoring tools to detect and alert on suspicious activity from deployed containers, assuming initial image vetting is not feasible. Correct answer is B. Implement an automated image scanning and policy enforcement mechanism within the CI/CD pipeline that blocks deployments of images failing predefined security and compliance checks. Explanation: this scenario presents a common challenge in Kubernetes operations, balancing the need for rapid deployment of new features with the imperative to maintain a secure and compliant operational environment. The risk matrix highlights potential vulnerabilities introduced by unvetted container images, which directly impacts the organization's adherence to security policies and potentially regulatory requirements related to data protection and system integrity. The professional challenge lies in implementing effective controls without unduly hindering development velocity. The correct approach involves establishing a robust, automated image scanning and approval workflow integrated into the CI/CD pipeline. This represents best professional practice because it proactively identifies and mitigates risks before vulnerable images reach production. Specifically, it aligns with the principles of Secure Software Development Lifecycle (SSDLC) and demonstrates due diligence in managing supply chain risks. By embedding security checks early, it ensures that only compliant and vetted images are deployed, thereby upholding the organization's security posture and any applicable regulatory mandates for system security and data integrity. This proactive stance is crucial for maintaining trust and avoiding potential breaches or compliance failures. An incorrect approach would be to bypass the scanning process for expediency. This failure is professionally unacceptable because it directly contravenes established security policies and best practices for Kubernetes operations. It introduces significant risk of deploying compromised or vulnerable software, potentially leading to security incidents, data breaches, and non-compliance with industry standards or regulations. Ethically, it demonstrates a disregard for the organization's security responsibilities and the protection of its data and users. Another incorrect approach would be to rely solely on manual review of scan results after deployment. This is also professionally unacceptable as it is reactive rather than proactive. Manual reviews are prone to human error, delays, and are not scalable for the dynamic nature of Kubernetes deployments. This approach fails to prevent the initial deployment of risky images, increasing the attack surface and the likelihood of security incidents. It also falls short of demonstrating a commitment to continuous security and risk management. Finally, an incorrect approach would be to ignore the findings of the image scanning tools altogether, assuming the developers have adequately secured their code. This is a critical professional and ethical failure. It demonstrates a lack of understanding of the complexities of containerized environments and the potential for vulnerabilities to exist in base images, dependencies, or configurations, even in well-written application code. Ignoring scan results abdicates responsibility for operational security and leaves the organization exposed to significant risks, potentially violating regulatory obligations related to system security and incident response. The professional reasoning process for such situations should involve 1. Understanding the identified risks and their potential impact, as presented in the risk matrix. 2. Evaluating available technical controls and operational procedures for mitigating these risks. 3. Prioritizing solutions that integrate security into the development and deployment lifecycle shift-left security. 4. Ensuring that chosen solutions are scalable, automated, and align with organizational policies and regulatory requirements. 5. Establishing clear communication channels between development, security, and operations teams to foster a shared responsibility for security. 6. Regularly reviewing and updating security controls based on evolving threats and organizational needs. Question 8. Compliance review shows that several container images deployed to the VMware Tanzu Kubernetes cluster have been flagged by the integrated security scanning tool for critical vulnerabilities. The development team is pushing for immediate deployment of these applications to meet a critical business deadline. What is the most appropriate course of action to ensure operational compliance and security? Option A. Investigate the flagged vulnerabilities to determine their actual impact and risk. If the risk is deemed acceptable for the short term, implement compensating controls and proceed with deployment while prioritizing remediation. Option B. Halt all deployments until every single flagged vulnerability is remediated, regardless of its severity or business impact. Option C. Grant the development team elevated privileges to bypass the security scanner for this specific deployment, with a promise to review security configurations later. Option D. Proceed with the deployment immediately to meet the business deadline and address the vulnerabilities in a subsequent patch cycle. Correct answer is A. Investigate the flagged vulnerabilities to determine their actual impact and risk. If the risk is deemed acceptable for the short term, implement compensating controls and proceed with deployment while prioritizing remediation. Explanation. This scenario presents a common challenge in cloud-native operations, balancing the need for rapid deployment and innovation with robust security and compliance mandates. The professional is tasked with ensuring that the Kubernetes environment, managed by VMware Tanzu, adheres to specific security policies without stifling development velocity. The challenge lies in interpreting and applying the VMware Tanzu for Kubernetes Operations Professional 2v0-71. 23. Syllabus's guidance on security and compliance within a dynamic operational context. The correct approach involves leveraging Tanzu's built-in security features and best practices for policy enforcement. This includes understanding how to integrate security scanning tools into the CI/CD pipeline, implementing network segmentation using Kubernetes network policies, and configuring role-based access control (RBAC) to limit privileges, adhering to the principles outlined in the 2v0-71. 23 syllabus, such as least privilege and defense in depth, is paramount. This approach ensures that security is not an afterthought but is woven into the operational fabric, aligning with the exam's focus on secure Kubernetes operations. An incorrect approach would be to bypass or ignore the security scanning results, assuming they are false positives without proper investigation. This directly violates the principle of due diligence and could lead to the deployment of vulnerable applications, exposing the organization to security breaches. Another incorrect approach is to grant overly broad permissions to development teams, circumventing RBAC controls. This creates significant security risks by increasing the attack surface and the potential for unauthorized access or accidental misconfiguration. A third incorrect approach is to delay the implementation of network policies, leaving the cluster vulnerable to lateral movement by potential attackers. These failures represent a disregard for established security best practices and the specific operational requirements for secure Kubernetes environments as covered by the 2v0-71. 23 exam. Professionals should adopt a systematic decision-making process. First, thoroughly understand the security requirements and the capabilities of VMware Tanzu. Second, integrate security checks early and continuously in the development lifecycle. Third, prioritize remediation of identified vulnerabilities based on risk. Finally, ensure that all security configurations are auditable and regularly reviewed. This proactive and integrated approach is essential for maintaining a secure and compliant Kubernetes environment. Question 9. The monitoring system demonstrates a consistent increase in latency for external API requests and a corresponding spike in CPU utilization on a subset of worker nodes. The ingress controller pods on these nodes are showing elevated request latency metrics. What is the most appropriate next step to diagnose and resolve this issue? Option A. Immediately scale up the number of worker nodes in the cluster to accommodate the increased load. Option B. Initiate a rolling restart of all application pods across the cluster to clear potential resource contention. Option C. Analyze the resource utilization, CPU memory network I/O, of the ingress controller pods and the specific worker nodes experiencing high CPU, correlating it with ingress traffic patterns. Option D. Focus exclusively on reviewing application logs for any error messages or exceptions related to API request processing. The correct answer is C. Analyze the resource utilization, CPU memory network I/O of the ingress controller pods and the specific worker nodes experiencing high CPU, correlating it with ingress traffic patterns. Explanation. This scenario presents a professional challenge due to the critical nature of Kubernetes cluster health and the potential impact of misinterpreting monitoring data on service availability and data integrity. The need to quickly and accurately diagnose performance degradation without causing further disruption requires a deep understanding of Tanzu Kubernetes operations and the underlying infrastructure. The professional must balance the urgency of resolution with the need for a systematic and compliant approach. The correct approach represents best professional practice because it aligns with the principles of proactive monitoring, root cause analysis, and adherence to operational best practices as outlined in VMware Tanzu for Kubernetes Operations Professional Guidelines. Specifically, it emphasizes isolating the issue to a specific component, the ingress controller, and then correlating that with resource utilization metrics. This systematic breakdown reduces the scope of investigation, minimizes the risk of unintended consequences from broad changes, and directly addresses the observed symptoms. This methodical approach is crucial for maintaining service-level agreements, SLAs, and ensuring compliance with operational standards. An incorrect approach that involves immediately scaling up all worker nodes without a targeted diagnosis is professionally unacceptable. This action fails to identify the root cause, leading to potentially unnecessary resource expenditure and masking the actual problem. From a regulatory and ethical standpoint, this demonstrates a lack of due diligence and a failure to manage resources responsibly, which could have financial implications and impact service stability. Another incorrect approach, such as restarting all pods in the cluster, is also professionally unsound. This is a brute force method that can disrupt ongoing operations, lead to data loss or corruption if not handled with extreme care, and does not guarantee a resolution. It bypasses the essential step of identifying the specific failing component, thus violating the principle of least privilege and potentially causing more harm than good. This approach lacks the precision required for professional operations and could be seen as negligent if it leads to service degradation. A third incorrect approach, focusing solely on application logs without considering infrastructure metrics, is also flawed. While application logs are important, performance degradation can often stem from underlying infrastructure or network issues. Ignoring these broader system-level indicators means the investigation is incomplete and may lead to misdiagnosis, wasting valuable time and resources. This demonstrates a failure to adopt a holistic view of the system, which is a cornerstone of effective Kubernetes operations. The professional reasoning process for this situation should involve 1. Observing and documenting the symptoms precisely. 2. Formulating hypotheses about potential causes based on the observed symptoms and system architecture. 3. Prioritizing hypotheses based on likelihood and impact. 4. Gathering relevant data, monitoring metrics, logs, events to test the prioritized hypotheses. 5. Isolating the problem to the smallest possible component or layer. 6. Implementing targeted remediation steps based on the confirmed root cause. 7. Verifying the resolution and monitoring for recurrence. 8. Documenting the incident, resolution, and lessons learned. Question 10. The evaluation methodology shows a scenario where a VMware Tanzu Kubernetes cluster is configured to host multiple independent tenants, each with its own set of applications and data. The primary operational goal is to ensure strict isolation between these tenants to prevent unauthorized access and data leakage, while also adhering to industry-specific compliance mandates that require granular control over network traffic and resource access. The professional must select the most appropriate strategy for implementing this tenant isolation within the Tanzu environment. Which of the following approaches best satisfies the requirements for robust tenant isolation and regulatory compliance in this VMware Tanzu Kubernetes Operations Professional scenario? Option A. Implement tenant isolation primarily through application-level security configurations and bypass native Kubernetes networking controls. Option B. Rely on the default Kubernetes networking behavior, assuming that namespaces inherently provide sufficient isolation for all tenants. Option C. Disable all network restrictions within the cluster to simplify management and improve application performance across all tenants. Option D. Implement Kubernetes network policies to define strict ingress and egress rules between namespaces, coupled with Tanzu's role-based access control RBAC, configured at the namespace level for each tenant. The correct answer is D. Implement Kubernetes network policies to define strict ingress and egress rules between namespaces, coupled with Tanzu's role-based access control, RBAC, configured at the namespace level for each tenant. Explanation. The evaluation methodology shows a scenario where a Kubernetes operations professional is tasked with ensuring the security posture of a multi-tenant VMware Tanzu Kubernetes environment. The challenge lies in balancing the isolation requirements of different tenants with the operational efficiency and centralized management capabilities offered by Tanzu. This requires a deep understanding of Kubernetes networking primitives, Tanzu's specific features for multi-tenancy, and the regulatory compliance landscape that governs data segregation and access control. Professional judgment is critical to select the most effective and compliant strategy, as misconfigurations can lead to security breaches, compliance violations, and operational disruptions. The correct approach represents best professional practice because it leverages Tanzu's built-in capabilities for network policy enforcement and namespace-based isolation. By implementing network policies that strictly define ingress and egress traffic between namespaces, and by utilizing Tanzu's role-based access control RBAC to manage permissions at the namespace level, the professional ensures that tenants are logically separated and cannot interfere with each other's workloads or data. This aligns with the principle of least privilege and adheres to common regulatory requirements for data segregation and access control in cloud-native environments, such as those mandated by data protection regulations that require strict controls over sensitive information. An incorrect approach that relies solely on the default Kubernetes network behavior without explicit network policies is professionally unacceptable. This failure represents a significant regulatory and ethical lapse because it neglects the fundamental security principle of network segmentation, leaving tenants vulnerable to unauthorized access and data leakage. Such an oversight would violate the spirit, if not the letter, of regulations requiring robust data protection and isolation. Another incorrect approach that involves disabling all network restrictions to simplify operations is equally problematic. This approach demonstrates a severe lack of understanding of security best practices and regulatory obligations. It creates an open network environment where any pod can communicate with any other pod across all tenants, leading to a complete breakdown of isolation and a high risk of security incidents and compliance failures. This directly contravenes regulations that mandate strict controls over data access and network traffic. A third incorrect approach that attempts to implement tenant isolation solely through application-level configurations, without leveraging Kubernetes or Tanzu's native networking and RBAC features, is inefficient and prone to errors. While application-level controls can add a layer of security, they are not a substitute for robust infrastructure-level isolation. Relying on this method alone would likely result in inconsistent security enforcement and would not meet the stringent requirements of many regulatory frameworks that demand verifiable and enforceable network segmentation at the infrastructure level. The professional decision-making process should involve a thorough assessment of the specific regulatory requirements applicable to the data being processed by each tenant, followed by an evaluation of Tanzu's features that can enforce these requirements. The principle of defense in depth should guide the selection of controls, prioritizing infrastructure-level security mechanisms like network policies and RBAC before considering application-level measures. Continuous monitoring and auditing of network traffic and access logs are essential to ensure ongoing compliance and security. Question 11. Compliance review shows that a critical production application is experiencing intermittent failures due to corrupted configuration data within a VMware Tanzu Kubernetes cluster. You have identified the specific data that needs correction, but the standard operational procedures require a multi-stage approval process for direct data modification, which would take too long to resolve the immediate outage. You have the technical capability to directly access and modify this data using privileged credentials. Option A. Directly modify the corrupted configuration data to restore application functionality, meticulously documenting all changes and the rationale, and immediately report the action to your supervisor for post-incident review and approval. Option B. Escalate the issue to the application development team and request they provide a new configuration, even if it means extended downtime, rather than directly intervening with the data yourself. Option C. Attempt to resolve the issue by restarting application pods and nodes, even though you suspect this will not address the root cause of the corrupted data, and wait for the standard approval process to proceed with data modification. Option D. Access the cluster and directly modify the corrupted configuration data without any documentation or immediate notification, assuming the fix will be successful and no one will notice. The correct answer is A. Directly modify the corrupted configuration data to restore application functionality, meticulously documenting all changes and the rationale, and immediately report the action to your supervisor for post-incident review and approval. Explanation. This scenario presents an ethical dilemma rooted in the principle of data integrity and the responsible use of privileged access within a Kubernetes environment managed by VMware Tanzu. The challenge lies in balancing the immediate need to resolve a critical production issue with the potential for unauthorized data manipulation, even if done with good intentions. The professional must navigate the tension between operational urgency and adherence to security policies and ethical conduct. The correct approach prioritizes transparency, accountability, and adherence to established protocols by documenting the access, the specific actions taken, and the rationale behind them. And by seeking post-incident approval, the professional upholds the principles of auditability and responsible system administration. This aligns with best practices for maintaining a secure and trustworthy operational environment, ensuring that all actions are traceable and justifiable, thereby preventing potential misuse of elevated privileges and maintaining the integrity of the data and the system. An incorrect approach that involves directly modifying sensitive data without explicit authorization or proper logging, even to fix an issue, represents a significant ethical and regulatory failure. This bypasses established security controls and audit trails, creating a blind spot in system monitoring and potentially leading to data corruption or unauthorized access that cannot be traced. Such actions undermine the trust placed in the operations team and violate principles of data governance and security. Another incorrect approach, which involves ignoring the issue due to fear of repercussions, fails to meet professional obligations to maintain system stability and resolve critical incidents, potentially leading to greater operational and business impact. This demonstrates a lack of proactive problem solving and a failure to escalate appropriately. Professionals should employ a decision-making framework that begins with understanding the immediate impact of the issue, followed by an assessment of available authorized tools and procedures. If authorized methods are insufficient, the next step is to consult with security and compliance teams to determine the safest and most compliant course of action, which may involve temporary, documented, and approved exceptions. Transparency and documentation are paramount throughout the process. Question 12. Compliance review shows that a critical production Kubernetes cluster, managed by VMware Tanzu, is experiencing intermittent performance degradation impacting customer-facing applications. To diagnose the issue, engineers require access to application logs and potentially pod-level metrics, which may contain sensitive customer information. The organization operates under strict data privacy regulations that mandate the protection of personal data. What is the most appropriate course of action for the operations team to take to resolve the performance issue while ensuring compliance with data privacy regulations? Option A. Implement a process to anonymize or pseudonymize sensitive data within the logs and metrics before accessing them for troubleshooting, or obtain explicit, documented consent from affected customers for data access, limiting access to essential personnel under strict supervision. Option B. Temporarily disable logging for sensitive data fields within the Kubernetes cluster to facilitate easier access for troubleshooting, with the intention of re-enabling them once the performance issue is resolved. Option C. Escalate the issue to senior management and legal counsel, halting all troubleshooting efforts until a comprehensive data privacy impact assessment and a new policy for accessing sensitive data are developed. Option D. Access the application logs and pod metrics directly, focusing solely on identifying the performance bottleneck, and address any data privacy concerns after the issue is resolved. The correct answer is D. Access the application logs and pod metrics directly, focusing solely on identifying the performance bottleneck, and address any data privacy concerns after the issue is resolved. Explanation. This scenario presents an ethical dilemma common in cloud operations, specifically concerning data privacy and access control within a Kubernetes environment managed by VMware Tanzu. The challenge lies in balancing the immediate need for troubleshooting with the imperative to protect sensitive customer data, adhering to regulatory frameworks like GDPR, assuming a European context for this exam's jurisdiction, as is common for VMware's global operations and professional certifications. The correct approach prioritizes data protection and compliance by anonymizing or pseudonymizing data before access, or by obtaining explicit consent and limiting access to only necessary personnel under strict supervision. This aligns with the principle of data minimization and purpose limitation, fundamental to GDPR. It ensures that, while operational issues are addressed, the privacy rights of individuals whose data resides within the cluster are upheld. This method demonstrates a commitment to responsible data handling and regulatory adherence, mitigating risks of data breaches and associated penalties. An incorrect approach that involves direct access to sensitive customer data without proper authorization or anonymization is a direct violation of data privacy regulations. This action could lead to unauthorized disclosure of personal information, a severe breach of trust and legal requirements. Another incorrect approach, such as delaying critical troubleshooting due to an overly rigid interpretation of data access policies, could negatively impact service availability and customer satisfaction, potentially leading to contractual breaches. Furthermore, attempting to bypass established security protocols, even with good intention, undermines the integrity of the security posture and creates a precedent for future noncompliance. Professionals should employ a risk-based decision-making framework. This involves identifying the potential risks associated with each action, considering the regulatory requirements, the impact on stakeholders, customers, the organization, and the ethical implications. When faced with such a dilemma, the process should include consulting with legal and compliance teams, documenting all decisions and actions, and seeking the least intrusive yet effective solution that upholds both operational needs and regulatory obligations. Question 13. Operational review demonstrates that the Kubernetes cluster's application deployment pipeline is experiencing frequent performance degradations and occasional security alerts post-deployment, impacting service availability. Which of the following process optimization strategies would best address these issues while adhering to professional operational standards? Option A. Focus exclusively on optimizing the network latency for all deployed applications, assuming that performance improvements will inherently resolve security and stability concerns. Option B. Implement automated pre-deployment checks within the CI/CD pipeline that validate application configurations against defined performance benchmarks, security policies, and compliance requirements before promoting to production. Option C. Introduce automated security scanning for all container images, but bypass performance and compliance validation in the deployment pipeline to expedite release cycles. Option D. Prioritize rapid deployment of new application versions by deferring comprehensive performance and security testing to post-deployment monitoring, with a plan to address issues reactively. The correct answer is B. Implement automated pre-deployment checks within the CI/CD pipeline that validate application configurations against defined performance benchmarks, security policies, and compliance requirements before promoting to production. Explanation. This scenario presents a common challenge in Kubernetes operations, balancing the need for rapid deployment and feature iteration with the imperative of maintaining operational stability and compliance. The challenge lies in the inherent tension between agility and control. Teams often push for faster releases, which can introduce new configurations or dependencies that, if not rigorously tested and validated against established operational standards, can lead to performance degradation, security vulnerabilities, or outright service outages. The professional challenge is to implement processes that enable speed without compromising reliability and adherence to the VMware Tanzu for Kubernetes operations professional framework, which implicitly guides towards robust, secure, and efficient operations. The correct approach represents best professional practice because it embeds process optimization directly into the development lifecycle through a continuous feedback loop. By integrating automated checks for compliance, performance, and security within the CI/CD pipeline, potential issues are identified and remediated early before they impact production environments. This proactive stance aligns with the principles of operational excellence and risk management, ensuring that deployments are not only fast but also stable and secure. This methodology minimizes the likelihood of incidents, reduces the cost of remediation, and builds trust in the platform's reliability, all of which are critical for professional Kubernetes operations. Each incorrect approach represents specific regulatory or ethical failures within the context of professional Kubernetes operations. Implementing a deploy first, fix later strategy is ethically irresponsible and professionally negligent. It prioritizes speed over the integrity of the service and the trust of users, potentially leading to significant downtime and data breaches. This approach fails to uphold the professional duty of care to ensure system stability and security. Automating only performance tests without considering security or compliance checks creates a significant blind spot. It allows for potentially vulnerable or non-compliant deployments to reach production, violating implicit professional obligations to maintain a secure and compliant environment. Similarly, focusing solely on security scans without validating operational readiness or performance metrics leads to a lopsided optimization. It might result in a secure but unusable or unstable application, failing to meet the broader operational objectives and professional standards of delivering reliable services. The professional decision-making process for similar situations should involve a risk-based assessment. Before implementing any change or adopting a new process, professionals must consider the potential impact on stability, security, and compliance. The goal is to establish a framework that incorporates automated validation at multiple stages of the deployment pipeline. This framework should prioritize early detection of issues, foster collaboration between development and operations teams, and ensure that all deployments meet predefined operational and security baselines. The decision should always lean towards a more controlled and validated approach, even if it means a slight increase in initial deployment time, as the long-term benefits of stability and security far outweigh the short-term gains of unchecked speed. Question 14. The performance metrics show a consistent increase in pod startup latency across several critical microservices within the VMware Tanzu Kubernetes environment. Which of the following actions is the most appropriate initial step to address this issue? Option A. Analyze Kubernetes event logs, node resource utilization, and container image build processes to identify potential bottlenecks. Option B. Focus on optimizing the application code of the affected microservices for faster startup. Option C. Immediately scale up the number of nodes in the cluster to accommodate increased demand. Option D. Restart all pods belonging to the affected microservices to clear any transient issues. The correct answer is A. Analyze Kubernetes event logs, node resource utilization, and container image build processes to identify potential bottlenecks. Explanation. The performance metrics show a consistent increase in pod startup latency across several critical microservices within the VMware Tanzu Kubernetes environment. This scenario is professionally challenging because it directly impacts application availability and user experience, potentially leading to service disruptions and reputational damage. The pressure to resolve such issues quickly can lead to hasty decisions that might overlook underlying systemic problems or introduce new risks. The correct approach involves a systematic, data-driven investigation to identify the root cause of the increased pod startup latency. This includes analyzing resource utilization, CPU, memory, network, examining Kubernetes event logs for scheduling or admission controller issues, reviewing the container image build process for inefficiencies, and assessing the health of the underlying node infrastructure. This methodical approach aligns with best professional practices for operations management, emphasizing proactive problem-solving and minimizing the risk of unintended consequences. It ensures that solutions are targeted and sustainable, rather than temporary fixes. An incorrect approach would be to immediately scale up node resources without a thorough investigation. This is professionally unacceptable because it fails to address the root cause, leading to unnecessary operational costs and potentially masking underlying issues that could resurface later. From a regulatory and ethical standpoint, this approach demonstrates a lack of due diligence and responsible resource management, which could be considered a failure to uphold operational integrity. Another incorrect approach is to arbitrarily restart pods or nodes. While this might offer a temporary reprieve, it is a reactive measure that does not resolve the underlying problem. It can lead to data loss or corruption if not managed carefully, and can disrupt ongoing operations. Ethically, this approach shows a disregard for system stability and a failure to implement robust troubleshooting procedures. A third incorrect approach is to focus solely on application-level tuning without considering the Kubernetes infrastructure. While application performance is important, Increased pod startup latency often points to infrastructure or orchestration bottlenecks. Ignoring these systemic factors means the problem will likely persist or reappear. This demonstrates a failure to adopt a holistic view of the system, which is a critical aspect of professional operations. The professional reasoning process for such situations should involve 1. Acknowledging the impact and urgency. 2. Initiating a structured troubleshooting methodology, starting with data collection and analysis. 3. Formulating hypotheses based on observed metrics and logs. 4. Testing hypotheses systematically, prioritizing changes that have the least impact on production. 5. Documenting all findings and actions. 6. Implementing a permanent fix and verifying its effectiveness. 7. Reviewing the incident to identify lessons learned and improve future response. Question 15. Quality control measures reveal that a recent series of application deployments via the CI/CD pipeline have bypassed certain automated security checks and resource constraint validations. The operations team is concerned about potential compliance drift and increased attack surface. Which of the following actions best addresses this situation to optimize the process and ensure ongoing compliance? Option A. Temporarily disable the bypass security checks and resource validations to maintain deployment velocity, with a plan to address them in a future maintenance window. Option B. Conduct a thorough review of the CI/CD pipeline configuration and associated policies to identify the specific points of bypass, re-enable and strengthen the automated checks, and validate their effectiveness through test deployments. Option C. Instruct development teams to manually re-verify all security and resource configurations for their applications before each deployment until the pipeline issue is resolved. Option D. Immediately roll back all recent deployments to their previous stable states and initiate a full manual audit of all deployed applications and their configurations. The correct answer is B. Conduct a thorough review of the CI/CD pipeline configuration and associated policies to identify the specific points of bypass, re-enable and strengthen the automated checks, and validate their effectiveness through test deployments. Explanation. Scenario analysis. This scenario presents a common challenge in Kubernetes operations, balancing the need for rapid deployment and feature iteration with the imperative of maintaining system stability and compliance. The pressure to deliver new services quickly can lead to shortcuts in established processes, potentially introducing security vulnerabilities or operational inefficiencies. The professional challenge lies in identifying and rectifying these deviations without stifling innovation or causing undue disruption. Adherence to the VMware Tanzu for Kubernetes Operations Professional Framework, which emphasizes robust operational practices, is paramount. Correct approach analysis. The correct approach involves a systematic review and revalidation of the CI/CD pipelines, adherence to defined security and operational policies. This aligns with the principles of process optimization by ensuring that the automated workflows are not only efficient but also secure and compliant. Specifically, reintegrating automated security scanning, e.g., container image vulnerability scanning, static code analysis, and policy enforcement checks, e.g., admission controllers for resource limits, network policies, into the pipeline ensures that deviations are caught early and corrected. This proactive stance minimizes the risk of deploying non-compliant or vulnerable artifacts, thereby upholding operational integrity and reducing the likelihood of security incidents or performance degradation. This approach directly supports the exam's focus on optimizing processes for reliable and secure Kubernetes operations. Incorrect approach is analysis. One incorrect approach is to immediately revert all recent changes without a thorough investigation. While seemingly safe, this can be overly disruptive, potentially undoing legitimate improvements and frustrating development teams. It fails to address the root cause of the deviation and can lead to a cycle of reactive fixes rather than proactive process improvement. Ethically, it can be seen as a failure to properly analyze and understand the impact of changes, leading to unnecessary operational friction. Another incorrect approach is to solely rely on manual audits after deployment. This is inefficient and reactive. Manual audits are prone to human error and are too late in the lifecycle to prevent issues from impacting production environments. This approach violates the principles of process optimization by not leveraging automation for continuous validation, increasing the risk of undetected compliance breaches and security vulnerabilities. From a professional standpoint, it represents a failure to implement best practices for modern, automated operational environments. A third incorrect approach is to prioritize speed of deployment over policy adherence, assuming that any issues will be addressed in a subsequent patch. This is a direct contravention of operational best practices and the principles of secure development. It introduces significant risk by knowingly deploying potentially insecure or non-compliant code. This approach demonstrates a lack of professional responsibility and a disregard for the potential consequences of such actions, including data breaches, service outages, and reputational damage. Professional reasoning. Professionals facing such a situation should employ a structured problem-solving approach. First, clearly define the observed deviation and its potential impact. Second, consult the established operational policies and compliance requirements relevant to the VMware Tanzu environment. Third, investigate the CI/CD pipeline to pinpoint the exact point of divergence from policy. Fourth, implement corrective actions that not only fix the immediate issue but also strengthen the pipeline to prevent recurrence. This might involve reconfiguring automated checks, updating policies, or providing additional training. Finally, document the findings, actions taken, and lessons learned to foster continuous improvement. This systematic process ensures that operational integrity is maintained while supporting efficient development workflows. Question 16. Assessment of the CI/CD pipeline optimization strategy for a VMware Tanzu Kubernetes environment, considering the introduction of a new microservice with significant architectural changes. What approach best balances rapid feature delivery with operational stability and security? Option A. Deploy the new microservice directly to production after a brief code review, relying on immediate manual observation for any emergent issues. Option B. Implement automated canary deployments with real-time performance and error monitoring, gradually increasing traffic to the new microservice while maintaining rollback capabilities. Option C. Prioritize deploying the new microservice to all production clusters simultaneously to ensure consistent feature availability across the environment. Option D. Focus solely on reducing the build and deployment times of the new microservice, deferring comprehensive testing and validation to a later stage. The correct answer is B. Implement automated canary deployments with real-time performance and error monitoring, gradually increasing traffic to the new microservice while maintaining rollback capabilities. Explanation. This scenario presents a common challenge in cloud-native operations, balancing the need for rapid deployment and feature iteration with the imperative to maintain stable and secure production environments. The core tension lies in optimizing the CI/CD pipeline for speed without compromising the integrity of the Kubernetes infrastructure managed by VMware Tanzu. Professionals must navigate this by implementing robust, automated processes that incorporate security and stability checks at critical junctures. The correct approach emphasizes a phased rollout strategy, leveraging progressive delivery techniques like canary deployments or blue-green deployments. This allows for controlled exposure of new versions to a subset of users or traffic, enabling real-time monitoring for performance regressions or security vulnerabilities before a full rollout. This aligns with best practices for operational stability and risk mitigation, ensuring that potential issues are identified and addressed early, minimizing impact on the broader user base. This approach is implicitly supported by operational guidelines that prioritize service availability and data integrity, which are foundational to maintaining customer trust and meeting service-level agreements. An incorrect approach that bypasses automated testing and validation before deploying to production directly violates principles of operational diligence. This introduces an unacceptable level of risk, potentially leading to widespread service disruption, data corruption, or security breaches. Such an action would be considered a failure to adhere to established operational best practices and could have significant reputational and financial consequences, potentially contravening implicit regulatory expectations around service reliability and data protection. Another incorrect approach, focusing solely on feature velocity without considering the impact on the underlying infrastructure's stability, overlooks the interconnectedness of application deployment and platform health. This can lead to resource contention, performance degradation, or even system instability, all of which undermine the overall operational efficiency and reliability of the VMware Tanzu Kubernetes environment. This demonstrates a lack of holistic operational thinking, prioritizing one aspect of performance over others without proper consideration of the trade-offs. Finally, an approach that relies heavily on manual intervention for critical deployment decisions, especially in a dynamic Kubernetes environment, introduces human error and delays. While manual oversight can be valuable, over-reliance on it in a high-velocity CI/CD pipeline is inefficient and prone to inconsistencies. This can lead to missed issues, slower response times to incidents, and a general reduction in the predictability and reliability of the deployment process, failing to leverage the automation capabilities inherent in modern cloud-native operations. Professionals should adopt a decision-making framework that prioritizes a risk-based approach to process optimization. This involves identifying critical control points in the CI/CD pipeline, implementing automated checks for functionality, security, and performance, and employing progressive delivery strategies for new deployments. Continuous monitoring and feedback loops are essential to iteratively refine these processes, ensuring that optimization efforts enhance both speed and stability. Question 17. Comparative studies suggest that optimizing CI/CD pipelines for Kubernetes operations can significantly improve deployment velocity. In a scenario where a financial services organization is leveraging VMware Tanzu for Kubernetes operations professional and must adhere to strict data privacy regulations, which approach to process optimization within the CI/CD pipeline would best balance agility with compliance and operational integrity? Option A. Focusing solely on increasing the throughput of code commits without establishing clear validation criteria or automated checks, assuming that post-deployment monitoring will catch any issues. Option B. Prioritizing rapid deployment of new features by reducing the number of manual review gates and automated tests in the CI/CD pipeline to accelerate the release cycle. Option C. Implementing automated security scanning, compliance checks, and robust rollback mechanisms directly within the CI/CD pipeline, ensuring all deployments are validated against predefined security and regulatory policies before reaching production. Option D. Introducing manual approval steps at multiple stages of the pipeline to ensure thorough human oversight, even if it significantly increases the time to deploy. The correct answer is C. Implementing automated security scanning, compliance checks, and robust rollback mechanisms directly within the CI/CD pipeline, ensuring all deployments are validated against predefined security and regulatory policies before reaching production. Explanation. This scenario presents a common challenge in cloud-native operations, balancing the need for rapid deployment and feature iteration with the imperative to maintain stability and compliance within a regulated environment. The professional challenge lies in identifying and implementing process optimizations that enhance efficiency without compromising security, auditability, or adherence to VMware Tanzu for Kubernetes operations, professional best practices, and any applicable regulatory frameworks that govern data handling and operational integrity within the Kubernetes ecosystem. The correct approach focuses on establishing robust, automated, and auditable CI/CD pipelines. This aligns with best practices for Kubernetes operations by ensuring that changes are consistently tested, validated, and deployed in a controlled manner. Automation reduces the risk of human error, which is a significant factor in operational incidents. Furthermore, integrating security scanning and compliance checks directly into the pipeline provides continuous assurance that deployments meet predefined standards, a critical aspect for regulated industries. This proactive approach to process optimization, emphasizing repeatability and verifiability, is essential for maintaining operational excellence and meeting compliance mandates. An incorrect approach that bypasses automated testing and validation introduces significant risk. This failure to implement a controlled deployment process directly contravenes the principles of secure and reliable operation, potentially leading to the deployment of vulnerable or non-compliant code. Such a deviation from established best practices can result in security breaches, data integrity issues, and audit failures, all of which carry severe regulatory and ethical implications. Another incorrect approach, focusing solely on speed without considering the impact on operational stability or security, is equally problematic. While agility is a goal, it must be achieved within a framework that safeguards against unintended consequences. Neglecting to incorporate necessary checks and balances, such as performance testing or security vulnerability assessments, can lead to the introduction of instability or security flaws that could have far-reaching negative impacts, including potential regulatory noncompliance and reputational damage. The professional reasoning process should involve a thorough assessment of existing operational workflows against the requirements of the VMware Tanzu for Kubernetes Operations Professional Framework and any relevant industry-specific regulations. This includes identifying bottlenecks, areas prone to manual error, and opportunities for automation. A risk-based approach is crucial, prioritizing optimizations that yield the greatest improvements in efficiency and stability while mitigating the highest risks. Continuous monitoring and feedback loops are also vital to ensure that implemented optimizations remain effective and compliant over time. Question 18. Cost-benefit analysis shows that a new VMware Tanzu feature offers significant operational efficiencies and potential cost reductions, but its integration might introduce new attack vectors and potentially impact existing compliance controls. From a stakeholder perspective, the operations team is eager to leverage these benefits, while the security and compliance teams are raising concerns about the potential risks. What is the most professionally responsible approach to evaluating and potentially adopting this new feature? Option A. Conduct a comprehensive security and compliance impact assessment involving relevant stakeholders before any deployment and develop mitigation strategies for identified risks. Option B. Rely solely on the vendor's documentation and assurances regarding the security and compliance posture of the new Tanzu feature, assuming it meets all necessary standards. Option C. Proceed with the adoption of the new Tanzu feature immediately to realize the cost benefits and address any security or compliance issues that arise post-implementation. Option D. Defer the adoption of the new Tanzu feature indefinitely until a perfect, risk-free solution can be identified to avoid any potential negative consequences. The correct answer is C. Proceed with the adoption of the new Tanzu feature immediately to realize the cost benefits and address any security or compliance issues that arise post-implementation. Explanation. The scenario presents a common challenge in cloud-native operations, balancing the immediate benefits of a new technology with the long-term implications for security and compliance. The stakeholder perspective is crucial here, as different groups will prioritize different aspects. For a VMware Tanzu for Kubernetes Operations Professional, understanding the regulatory landscape is paramount. The exam syllabus for 2V0-71-23 emphasizes adherence to operational best practices within a defined regulatory framework. In this context, the challenge lies in ensuring that the adoption of a new Tanzu feature, while offering potential cost savings and efficiency gains, does not inadvertently introduce security vulnerabilities or violate existing compliance mandates. Careful judgment is required to weigh the tangible benefits against the potential risks and to ensure that all decisions are defensible from a compliance and security standpoint. The correct approach prioritizes a thorough, documented assessment of the new Tanzu feature's impact on the existing security posture and compliance framework. This involves engaging with security and compliance teams early in the evaluation process, conducting rigorous testing in a non-production environment, and ensuring that any implementation is accompanied by updated security policies and operational procedures. This approach represents best professional practice because it aligns with the principle of security by design and proactive compliance management. It demonstrates a commitment to maintaining a secure and compliant operational environment, which is a core responsibility for professionals in this domain. Adhering to established security controls and compliance requirements, even when faced with pressure for rapid adoption, is ethically sound and professionally responsible. An incorrect approach would be to proceed with the implementation based solely on the perceived cost benefits without adequate security and compliance validation. This could lead to regulatory violations, data breaches, and significant financial and reputational damage. For instance, bypassing established security review processes or ignoring potential compliance gaps would be a direct failure to uphold professional standards and regulatory obligations. Another incorrect approach would be to assume that the vendor's claims of security are sufficient without independent verification. This over-reliance on third-party assurances without due diligence is a common pitfall that can lead to unforeseen security weaknesses. Furthermore, prioritizing speed of deployment over thorough risk assessment demonstrates a lack of professional judgment and a disregard for the potential consequences of insecure or non-compliant operations. The professional reasoning process for similar situations should involve a structured risk assessment framework. This includes identifying potential threats and vulnerabilities, evaluating the likelihood and impact of those risks, and determining appropriate mitigation strategies. Stakeholder engagement is critical throughout this process, ensuring that all relevant parties are informed and have an opportunity to contribute to the decision-making. Documentation of all assessments, decisions, and mitigation plans is essential for auditability and accountability. Professionals should always err on the side of caution when security and compliance are at stake, and be prepared to articulate the rationale behind their decisions, especially when they deviate from the path of quickest implementation. Question 19. To address the challenge of ensuring that all new applications deployed on VMware Tanzu Kubernetes Grid (TKG) environments adhere to strict organizational security policies and regulatory compliance mandates, without hindering the rapid deployment cycles expected by the development teams, which of the following approaches best aligns with best professional practices for Kubernetes operations? Option A. Implement granular, automated security policies using VMware Tanzu Service mesh that define and enforce network segmentation, access controls, and workload behavior directly within the TKG clusters, integrated into the CI/CD pipeline. Option B. Defer security validation and policy enforcement for new applications until after they have been deployed to production and are actively running. Option C. Rely on manual security code reviews and ad hoc firewall rule configurations managed by the security team for each new application deployment. Option D. Focus security efforts solely on configuring cluster-level ingress and egress firewall rules to control traffic entering and leaving the TKG environment. Correct answer is A. Implement granular, automated security policies using VMware Tanzu Service mesh that define and enforce network segmentation, access controls, and workload behavior directly within the TKG clusters, integrated into the CI/CD pipeline. Explanation. Scenario analysis. This scenario presents a common challenge in cloud-native operations, balancing the need for rapid application deployment and innovation with the imperative to maintain a secure and compliant Kubernetes environment. The stakeholder perspective is critical here, as different teams have competing priorities. The development team prioritizes speed and flexibility, while the security and compliance teams focus on risk mitigation and adherence to established policies. The challenge lies in finding a solution that satisfies both, without compromising the integrity of the platform or introducing unacceptable security vulnerabilities. This requires a deep understanding of the VMware Tanzu Kubernetes Operations Professional 2V0-71. 23. Domain, specifically around policy enforcement and security best practices within a Kubernetes context. Correct approach analysis. Implementing a policy-driven approach using VMware Tanzu Service meshes policy enforcement capabilities represents best professional practice. This aligns directly with the principles of DevSecOps and the need for automated security controls. By defining granular policies that govern network traffic, resource access, and workload behavior, organizations can ensure that applications deployed on Tanzu Kubernetes Grid (TKG) adhere to security and compliance requirements without manual intervention. This approach leverages the declarative nature of Kubernetes and the advanced policy features of Tanzu Service mesh to enforce security at runtime. This is crucial for meeting regulatory obligations that mandate continuous monitoring and enforcement of security controls, preventing unauthorized access, and ensuring data integrity. Incorrect approaches analysis. Relying solely on manual security reviews and ad hoc firewall rules is a significant regulatory and ethical failure. This approach is inherently prone to human error, inconsistencies, and delays, making it impossible to guarantee continuous compliance with evolving security standards. It fails to provide an auditable trail of security configurations and enforcement, which is often a requirement for regulatory compliance. Furthermore, it creates a bottleneck for development teams, hindering agility and innovation. Implementing security measures only at the cluster ingress/egress points, without granular control within the cluster, is another failure. While important, this provides only a perimeter defense and does not address internal threats or the security posture of individual workloads. This leaves the environment vulnerable to lateral movement by attackers and fails to enforce policies specific to application communication or resource access within the cluster, which is often mandated by compliance frameworks. Ignoring the security implications of new application deployments until after they are in production is a critical oversight. This reactive approach is fundamentally insecure and increases the risk of breaches and non-compliance. It violates the principle of security by design and fails to proactively identify and mitigate potential vulnerabilities before they can be exploited. This can lead to significant financial penalties and reputational damage due to regulatory non-compliance. Professional reasoning. Professionals should adopt a proactive, policy-driven security posture. This involves understanding the specific regulatory requirements applicable to their organization and leveraging the capabilities of their platform, such as VMware Tanzu Service Mesh, to automate policy enforcement. The decision-making process should involve close collaboration between development, security, and operations teams to define clear security policies that are integrated into the CI/CD pipeline. Regular audits and continuous monitoring are essential to ensure ongoing compliance and to adapt to new threats and regulatory changes. Question 20. The performance metrics show a steady increase in CPU and memory utilization across several Kubernetes clusters managed by VMware Tanzu, accompanied by a noticeable uptick in application error rates and API latency shortly after a new feature was deployed to production. Stakeholders are expressing concern about the delay in delivering subsequent features and are pushing for continued rapid development cycles. What is the most appropriate immediate course of action for the operations team? Option A. Initiate a deep dive investigation into the root cause of the increased error rates and latency, correlating it with the recent feature deployment and resource utilization trends, while temporarily pausing further non-critical deployments. Option B. Immediately roll back the recently deployed feature to revert performance metrics to baseline levels, and then proceed with the planned feature development. Option C. Continue with the planned feature development and deployments, assuming the performance metrics are transient and will self-correct as the system scales. Option D. Focus solely on optimizing resource allocation and scaling up cluster capacity to accommodate the increased utilization, without investigating the root cause of the errors and latency. The correct answer is A. Initiate a deep dive investigation into the root cause of the increased error rates and latency, correlating it with the recent feature deployment and resource utilization trends, while temporarily pausing further non-critical deployments. Explanation. Scenario analysis. This scenario presents a common challenge in cloud-native operations, balancing the need for rapid feature deployment with the imperative to maintain system stability and security. The performance metrics, while indicating an upward trend in resource utilization, do not immediately flag a critical failure. However, the rapid increase in error rates and latency, coupled with the stakeholders' focus on new feature velocity, creates a tension. The challenge lies in interpreting these metrics within the context of operational best practices and potential regulatory compliance, without overreacting to transient fluctuations or, conversely, ignoring warning signs that could lead to service degradation or security vulnerabilities. The pressure from stakeholders to prioritize new features adds a layer of complexity, requiring a nuanced approach that considers both technical and business imperatives. Correct approach analysis. The correct approach involves a proactive and data-driven investigation. This aligns with the principles of responsible operations and, by extension, regulatory adherence to maintaining service availability and data integrity. By initiating a deep dive into the root cause of the increased error rates and latency, the operations team demonstrates due diligence. This investigation should encompass examining application logs, Kubernetes event streams, network traffic, and resource allocation within Tanzu. The goal is to identify whether the performance degradation is directly attributable to the new feature deployment, an underlying infrastructure issue, or a combination of factors. This methodical approach ensures that any remediation actions are targeted and effective, minimizing disruption and upholding service-level agreements, SLAs, which are often implicitly or explicitly tied to regulatory requirements for service continuity. This proactive stance is crucial for maintaining trust with stakeholders and ensuring compliance with operational standards. Incorrect approach is analysis. Ignoring the metrics and continuing with further deployments is professionally unacceptable because it disregards clear indicators of system stress. This failure to monitor and respond to performance degradation can lead to cascading failures, service outages, and potential data loss, which could have significant regulatory implications, depending on the nature of the application and data being handled. It demonstrates a lack of operational discipline and a disregard for the stability of the platform. Immediately rolling back the new feature without a thorough investigation is also professionally problematic. While it might seem like a quick fix, it bypasses the opportunity to understand the true cause of the issue. The problem might not be solely with the new feature, and a rollback could be unnecessary, impacting the business's ability to deliver value. Furthermore, if the issue is indeed with the new feature, failing to diagnose it properly means the underlying vulnerability or bug remains, potentially resurfacing with future deployments. This approach lacks analytical rigor and can lead to inefficient use of resources and repeated issues. Focusing solely on the stakeholders' desire for feature velocity without addressing the performance degradation is a critical failure. This prioritizes business expediency over operational integrity and security. It creates a high-risk environment where system stability is compromised, potentially leading to breaches, compliance violations, and reputational damage. This approach neglects the fundamental responsibility of an operations professional to ensure the reliable and secure functioning of the platform. Professional reasoning. Professionals in this situation should adopt a structured problem-solving framework. First, acknowledge and validate all reported metrics and stakeholder concerns. Second, prioritize investigation based on the severity of the observed issues. Error rates and latency are significant. Third, gather data systematically, leveraging tools within VMware, Tanzu, and Kubernetes to pinpoint the root cause. Fourth, communicate findings transparently to stakeholders, explaining the technical implications and potential risks. Fifth, propose a remediation plan that balances operational stability, security, and business objectives. This might involve targeted fixes, phased rollouts, or temporary performance tuning. Finally, document the incident, the investigation, and the resolution for future reference and continuous improvement. This process ensures that decisions are informed, justifiable, and aligned with both technical best practices and any applicable regulatory mandates.